Hi guys, welcome back to my channel. In this video, I'll be taking you through triple integrals. In our previous lessons, we've tackled double integral over the general region, iterated integrals as well as double integrals in polar region. So we start with triple integrals in this section. What is triple integrals? So here we are going to see three integral signs over a box, right? And the box has three dimensions. So this is the first type of triple integrals you see, and it's a common type and the easiest of all. So this is very direct. Your first box goes in for what? Your inner function. Then the second box also continues that way, right? So we go in. So we go this way. So we have xyz, right? So xyz, and if you want to find the limit of the integral, you have to arrange it in a manner which you will be comfortable with. So you can choose to perform some of the integral. Maybe you will do the z first, the x first, the y first. So that one depends. But you'll be given the region, right? So you'll be given the region and you have to start with your arrangement as possible. Okay. So now let's see. Always take note that the very first one on the left, the very first one, sorry, on the right, okay, the very first one on the right, that will go for the outer, okay, that will go for the outer. Or you can say that the very first one here is for the innermost, followed by the second inner, and this go for the outermost, okay, that'll go for the outermost. So here I'll have my, you know that x, y, z, right? So the first one be x, so I'll have 2, 3 for the inner, then I'll move out towards 1, 2, then I'll move out towards 0, 1. Then the function 8xyz. So the first one is what for x, right? So I'm going to have the x, the y, and the z. As simple as that. The x, the y, the z. So here, meaning that we are going to integrate with respect to what x first, right? So integrating with respect to x first, what are we getting? We are going to get integral 0 to 1, integral 1 to 2. But with respect to x, I'm going to have 4 s squared yz from 2 to 3, right? Then I'll have dy dz. I'll put in my limit, right? So integral 0 to 1, integral 1 to 2. When I put in my limits, x will give me what? 9. I'll have x 3 squared is 9. So I'm going to have 36 y squared. Then I forgot my z. So there should be z, right? So this is z. So I think I'm messing up here. Yep, so let me clean this. So here we are putting it our limit. Wherever we see x, you put 3, then minus, you put 2. So x here, when I put 3, I'm going to get 9, right? So 9 times 4 is 36. That's what I wrote here. And I have my yz. Minus, when I put 2, 2 squared is 4, 4, 16 yz, right? Then I'll bring my dy dz. So 16 minus this, I'm going to get 20 yz. So I have integral from 0 to 1, 1 to 2 yz. That will be 20 yz dy dz. So the next I'm going to integrate with respect to y, and I'll have integral 0 to 1. Integrating this with respect to y, I'm going to have 10y squared z. Limit 1 to 2. So here I'll have 0 to 1. When I put 2 here, 4, 40z. When I put 1, 10z. That should give me what? 30z dz. So at this point, I integrate this with respect to z. That will give me 15z squared from 0 to 1, right? So from 0 to 1, what do we get? You're going to get 15